It's here. It's IPv6. In this nugget, we're going to take a look at the next generation TCP/IP protocol suite. So what gets all the press with IPv6? Well, it's certainly the enhanced address space that is available. You see, when IPv4 was designed, as you know, it was done with a 32-bit address space. And at the time, they looked at this and said, that's going to accommodate more IP addresses than we will ever need. So when they started to run out, they realized, okay, look, and they being the standards makers for all this stuff, they said, look, let's go ahead and in the next generation of IP, IPv6, let's do a substantially larger address. There you can see an IPv6 address. Notice it is no longer the dotted decimal notation that we are used to with IPv4 in its 32 bits. Instead, it is a hexadecimal representation separated by colons. Remember, each of these hex digits represents 4 bits. So if you do the math here, we see there are 32 of those hex digits, and that's 32 times 4. That's a 128-bit address space. Now, you look at this and you go, oh boy, that address space is unwieldy. I mean, that is so cumbersome. I can actually memorize certain IP addresses like the famous 192.168.0.1, for example, that we would see internally on a lot of default gateways. But when you look at the IPv6 address, it's pretty brutal. There's some good news about this address, and that is there are 2 things you can do to shorten them. 2 rules for shortening that I want you to know. One is that you can omit any leading zeros, and you can do this as many times as you want. Number 2 is that you can represent consecutive zeros as colon. You can only do this once in the address, however. Okay, so let's take a look at this address that we have right here in a shortened form. And I'm looking at it, and wow, look at all of these zeros right here. So I can represent that as colon in this address. I can only do that once. So there's my one opportunity in this particular address. And then I can omit any leading zeros. So my shortened form would be 2001 colon DB8. Notice I just dropped a leading zero. That's fine. 3C4D colon 15. Notice I just dropped 2 leading zeros. Here's my colon trick. And then 1A2F colon, not colon, but colon 1A2B. So it's still pretty cumbersome, but notice we dropped some leading zeros. We did our colon trick for all of those zeros, and it is a bit more succinct. Now, this address space is so massive. Once again, we're in a situation where we think we would never run out of addresses. The standards makers actually don't say that, though. They just say the 128-bit address space gives us enough for the foreseeable future. The other thing that's neat is with IPv4, they gave out most of the space. They assigned most of the space right out of the gate. With IPv6, they're only assigning a small sliver of the space, with the majority of the address space being reserved for future use. If you have all these unique addresses, can't you say goodbye to network address translation? And the answer is yes, you can. There still is NAT-like mechanisms in IPv6, but we are not going to need to use them most likely because there are more than enough unique addresses for every device that exists on the planet right now. I'm not kidding. Every single device that exists on the planet right now, there's enough addresses for. And when I say device, I'm talking about appliances and cars and all kinds of things. In fact, this really hinges on the Internet of Things terminology, right? Where everything's going to start becoming internet connected, and IPv6, the massive address space, will make that a possibility. It's nice that NAT can be destroyed, network address translation, because network address translation breaks how the internet is supposed to work. What I mean by that is they always intended for the internet to be a conversation between one unique and trackable address and another unique and trackable address. When NAT was introduced as a band-aid for the IPv4 address shortage, it broke that central paradigm of the internet. It broke the fact that there would be two unique and trackable addresses having a conversation. So we love the fact that we can get back to the internet the way it was supposed to be. Now, there's just so many things that set our CBT nuggets apart from all other self-paced training out there on the planet. And one of those things is the fact that every single one of my nuggets is carefully reviewed by multiple people. They're looking for things like spelling errors. There's others looking for things like technical errors. One of the reviewers had a great idea for this nugget, and it was that I provide another example of that address compression. After all, practice makes perfect. And this one has something interesting in it when we look. Here's a bunch of zeros, and then here's two fields of all zeros. What would we do here for the most efficient compression? Well, we would do obviously 2001 colon, we could do 56, dropping those leading zeros. Then here in this field, I would do a 0. You see what I'm doing is I'm dropping the 3 leading zeros, but as far as the colon trick, I'm going to save that for this big group. Then we'd have 1ADF, then our colon, then 2AB4, colon, 1A2B. And there you have it. This is the new compressed address. Notice we could still drop some leading zeros here, but we saved the colon abbreviation for this large group of 8 consecutive hexadecimal zeros. And I've got more good news for you. We can verify our practice compressions to ensure that we're doing this correctly. If you head up to the Ultra Tools website, you'll see there's an IPv6 compress tool. You can see I pasted our example in, and I ensured that our compressed address that we came up with together was indeed correct. But it's somewhat disturbing that there's so much focus on this enhanced address space because IPv6 brings such an incredible rich set of benefits to us beyond just being able to number this incredible number of devices around the planet. These are just some. I want to emphasize that these are just some of the advantages that we run into. One of my favorites, so I listed it first, is the auto configuration capability. Sure, we can have DHCP for IPv6, but we don't really need it. So you can have a device come online, and you can have this device receive its configuration from the router. Yeah, the device comes up and says, hey, you're my local router, please give me my config, and there is an auto configuration of the config. Think of what this would do for renumbering. So in situations where we want to go ahead and deploy new address space, we can have these devices auto-configured with new address space, no problem. Speaking of that, by the way, interfaces are set up to handle right out of the gate many different IPv6 addresses. So we are not limited to a single address per interface like we are so used to in an IPv4 world. Security dramatically enhanced. Let me give you one good example. In an IPv4 world, we can do IPsec, but IPsec is not mandatory, so you don't always see it. In IPv6, IPsec is absolutely mandatory. Every single IPv6 device must support IPsec. They don't have to engage in it, but they absolutely have to support it, which gives us great flexibility when it comes to actually securing things down the road. Mobility is worked on, so things are so much easier when it comes to maintaining your address as you move from one cloud to the next. There is a fixed header size. In fact, these three are kind of grouped together to show you how they worked on efficiencies. In IPv4, your header size, the IP header size, can be variable. That causes processing and overhead issues. In IPv6, the header is a fixed size. I've mentioned in other nuggets here how broadcasts are eliminated in IPv6. They don't exist. If you need to send something to everyone, you would use the appropriate multicast address instead. Fragmentation is taken away from the routers. They don't have to worry about it. That burden is placed on the hosts. So the host will find out the maximum transmission unit. The host, if necessary, will fragment the packet, and the receiving host can take care of the reassembly. Offloading this duty from the routers, again, has great implications for the efficiency of our networking. But here's the deal. As awesome as all this is, it's not like someone can send out a memo and we shut down the internet next Tuesday to make this transition. So what they did was they built in remarkably cool transition mechanisms. One that I'd like you to know is simply called dual stack, and that is the fact that your particular interface is going to be able to do IPv4 as well as IPv6 simultaneously. What can happen is, as all of your devices are making the transition to v6, you can start peeling back the v4. We probably in our lifetimes won't see the complete end of IPv4. The pockets of it will just get smaller and smaller and smaller as more devices transition to an IPv6 world. As you might guess, there's tons of tunneling mechanisms that exist as well. So if you have a pocket of v4, and you connect this pocket of v4 to another pocket of v4 over a cloud that is v6 only, no problem. We can encapsulate the v4 into v6, de-encapsulate the v4, leaving the v6 cloud, and again, rich tunneling mechanisms exist to ensure that v4 and v6 can coexist for decades to come as we make the transition process. Now, I really hope I've piqued your interest in IPv6 in this particular nugget, and if I have, check out our IPv6 course here at CBT Nuggets by none other than Keith Barker. Notice he's going to go into detail for you in the routing protocols, in various functionality like auto configuration and security, and of course, he'll spend a lot of time looking at those transition mechanisms that I alluded to. So super interesting nuggets here focused in on the next generation of IP. And I started this particular nugget by saying, in a rather creepy fashion, it's here. And just to kind of prove that as we wrap up here, I've just done an IP config with the all switch on my Windows host. And when you look in here, you can see, absolutely, we are totally ready, fired up to go for IPv6. Here you can see the link local IPv6 address that has been automatically configured on my Windows host. This allows me to communicate with my local IPv6 speakers, one of which can be a router, and that router can be configured to automatically assign me my global IPv6 information. I mentioned DHCP, which is a possibility for v6, and you can see some information here regarding that in the configuration as well. Not necessary that we use DHCP, remember, in the v6 world, but it would be there as an option. So it really is here, and how much of it we're using is going to vary from organization to organization. Well, I sure hope you enjoyed this look at IPv6 with a focus on addressing and, of course, the benefits. I sure hope you found this nugget informative, and I'd like to thank you for viewing.